Hello everyone, my name is Rasul. I work in PAC team of Ethereum Foundation, and today I want to talk about social recovery. So what is social recovery? Social recovery is a mechanism to restore control over an account when the original signing key is no longer usable by executing a predefined recovery procedure that involves other actors. So the target here is non-custodial accounts like EA or smart accounts, and it's like usually applicable when the original key is lost or destroyed. And recovery relies on protocol-defined rules, not on a support desk or a single master key. So by itself, social recovery should be non-custodial as well. So there are kinds of social recovery. First one is off-chain recovery, and another one is like on-chain recovery. So off-chain recovery is mostly when the off-chain recovery is when recovery process happens fully off-chain. So a good example of this is, let's say you have your private key and you want to split it across into multiple parts and give these shares to your friends. And then when your friends present their share, you can set also like N and M threshold parameters. And when N of your friends present their share, the private key will be restored. And on-chain recovery is basically fully on-chain mechanism. It's contract-based, and it also involves multiple actors. We call them guardians. And here guardians sign their transaction with their sign-in mechanism or any others auth method, and then they can also jointly authorize a new key for your account. So what we are trying to build in our team is social recovery SDK, so that wallets can integrate social recovery features. So right now, as you know, most of the wallets, they don't support social recovery features, or at least they don't support trustless, like self-custodial social recovery features. That's why we are trying to build this SDK. So before going further, I want to tell you that it's not public yet. It will be public soon, but generally I think it's good to share the details of our work, our progress, our challenges. So first I want to share our design goals. So the design goals is basically that no single party can unilaterally take over accounts. Then also, of course, N of M approval from multiple actors, and of course time locks. Different authentication mechanisms. We can call them classes as well for guardians with for security guarantees is recommended to have like one of each class policy. No dependency on centralized services, and also guardian privacy, so that the guardian set shouldn't be trivially exposed on chain. And also another important point here, another important goal is to have really good UX, so that recover my wallet procedure, that non-developers can completely recover my wallet procedure similar to forgot my password in What2. So what is social recovery SDK? Basically, we distinguish it into two components. One is like smart contracts, and it's basically interfaces and contracts for guardians. We have auth adapters. It's basically adapters on chain, like smart contracts that verify different auth methods. And something to manage recovery policies. We call it Recovery Manager. And client SDK is also kind of similar in that sense. It consists of auth manager, basically a bunch of different auth methods like ZK email, passkeys, verifiable credentials, etc. And wallet UI, helpers for configuration and recovery. And for you to understand general flow, is basically you have configuration, you open the wallet, like settings, you pick auth methods and guardians, the number of guardians, you define N of M and time locks, and then for recovery, basically you initiate recovery like from guardian's side. They authenticate and approve, and then contracts enforce the policy and rotate the accounts key. So I think I'm gonna skip this slide. So we had like two architectural options for on-chain recovery when we're designing this. So first option was to have like a monolithic recovery manager, and another option was to have composable recovery. So what is monolithic recovery manager? It's basically one single smart contract that basically manages all of the logic. And it's the same contract that verifies all guardian proofs, like signatures, ZK proof, etc. And so the same contracts perform owner and key rotation on the target account. So pros of this model is basically, it's very simple. It's one place for all the logic. And cons, it's that it's tightly coupled to specific auth methods. It's not non-scalable. It's hard to add something new. So that's why there is like another option. It's called composable recovery. And here, composable recovery is basically that authentication methods are implemented in Guardian-specific contracts, not inside one monolith. And recovery manager is implemented using existing primitives, for example, safe. And base account grants limited recovery privilege to a policy/aggregator. In our case, it's safe contract. So pros here is that it's easier to manage recovery policies, but cons is that there is like additional deploy costs for Guardian accounts. So like approximately design of composable approach is that first step, you have to derive deterministic addresses using create2 for Guardians and store the commitments to Guardian's data instead of plain text. So basically it's needed for Guardian's privacy. Then we create special recovery, special purpose recovery safe. Like multi-sig, where Guardians are the signers. And then in the safe, we can configure NLM policy and optionally install a time lock model there. And then we can grant a privilege to the smart account we are trying to set social recovery for. It can be a smart account or like 7702 enabled EOA. And then during recovery, important point here is that when we set the Guardians in the safe, we don't even need to deploy the contracts. We basically calculate the address using create2, and only when recovery happens, we already will be able to deploy smart contracts for Guardians, and then recovery safe will collect approvals, satisfy NLM, and call the smart account to execute the key rotation. Yeah, so that's generally it. A few challenges that I want to talk about here is that there is public key infrastructure challenges for some auth methods such as zkEmail and zkJWT. So the problem here is that zkEmail and zkJWT Guardians rely on signatures and public keys from external issuers like mail servers, auth, and JWT providers. On-chain verification needs correct issuer public keys, and there are no trustless way to port Web2 data into Web3. It's basically like an Oracle problem. And some of the auth, like mail providers, they support DNSSEC, but like most of them don't support this. And self-hosted DKIM and JWT registries can silently become outdated as well. So possible solution here is that for now we are sticking to the first solution of basically self-updated registries with DAO-governed registries as a fallback. So it's basically your registry, and in the UI there's like some from time to time, it's like let's say one time in each 6 months, wallet pings you to update your self-hosted registry, to update the registry. And if the user is not active, we can just put it in protocol that it will be switched to a DAO-governed registry. And another possible solution is ERC 7969, but it's still in draft. It's basically a way that says that there should be like a DKIM registry on Ethereum directly. And another problem is also a cross-chain recovery UX. And problem here is that accounts and assets are spread across multiple chains. And when you do a recovery on one chain, let's say on Ethereum, you recovered your wallet, but then there is like notification. You should do that the same stuff, the same process through like for all other layer 2s, for example. And that's like very bad UX. And possible solution here is basically, to wait for this REP to be accepted. It's like REP 7728. It's L1S load, precompile, and key stores. Yeah, so it's basically, there's going to be like one possible way to do it. There will be like a key store on layer 1, and when the recovery happens, it will be updated in this specific key store, and then all of the layer 2s, they will be able to just read from this storage. That's it. Thank you.